Alright, sorry crew. I needed to head home today. I was just not feeling very good. So before I left though, I wanted to quick make this video so that you guys can pretty much do the same thing we did first hour. We can stay on track. But what we're going to be doing here is just solving some algebraic proofs and showing you how that we can do that. So what I would like you to first of all try and do is I want you to actually pause the video and I want you to try and see if you can solve this equation. So yes, that means please go and pause the video and try and see if you can work this out. All right, let's go ahead and see how you did. So first thing that you should be doing with this equation is you should be using the distributive property to solve it. So 2 times x is 2x. 2 times 3 is a plus 6. Now be very careful on this next distributive property here because I want to distribute the negative 3. Negative 3 times x is a negative 3x. Negative 3 times a positive 1 is a negative 3. That equals 4x minus 12. Next, what I can do here is we can combine some similar terms. So 2x and a negative 3x can be put together and get a negative 1x. And I can also take these positive 6 and a negative 3 and I can add those together. They're on the same side. So that gives me positive 3 equals 4x minus 12. I'm someone who likes to typically bring things over to the left-hand side. So now I'm going to bring my x over by subtracting 4x from both sides. Negative 5x plus 3 is equal to negative 12. Then I need to subtract 3 from both sides to leave me with negative 5x is equal to negative 15. And then I can divide by negative 5. So that I'm left with x is equal to positive 3. If you did not get positive 3, what I want you to try and do is definitely look back and see where did you make your mistake. What we're going to be looking at now is working with algebraic proofs, and I'm actually going to be giving you the answer, but you're going to have to show me how to get there, and you're going to be having to do all the pieces in between it. Now, if I was there right now, I would have you cut out a bunch of little strips of paper and see if you could organize them in beginning to end here. But since I'm not there and I don't want to make too much work for someone who might not exactly be familiar with this, I'm just going to go ahead and take a look for us. So right here I have an equation that I'm starting with, and I have a bunch of different slips. And now I want to try and order them from beginning to end. And I'm going to end with a is equal to negative 11 because that's my goal in sight. Well, kind of like that last problem that we just did, we would use our distributive property to get to the next point. So 2 times 5 is 10, 2 times negative 3 is negative 6, negative 4 times a is negative 4, negative 4 times 7 is negative 28. So there's my next step. From there, I can combine like terms like we did, and that means we can put the constant terms together, which is the a's together, negative 6a and 4a, which joins together to give us negative 10a. I still have, oops, I think I got the wrong one here. This is what I'm looking for, yes. And so now when I combine those, I've got negative 18 minus 10a equals 92. From here, since I'm solving for a, I would want to add 18 to both sides. That's what this one's showing us to do. And once I do that, 92 plus 18 is 110. I'm left with negative 10a on the left. And then I could go ahead and I could divide. Now, if you notice here, I'm creating these steps, and it's kind of making a column of the two. We are venturing into this world of what a two-column proof is. And in the part to the left right here, we have the reasons. And then on the right here, we are going to have the statements. Now, you might be asking us, what is a statement? Well, a statement is going through and explaining what we are doing from each and every step to get to the final conclusion. So I'm going to go through a couple possible statements with you right now. All right, so All right, so first of all, what we have is we have the addition and subtraction property. And what this is pretty much doing is when we solve equations and we try to isolate the variable and we add 5 to both sides of the equation, you are doing the addition property. Here it says that if A equals B, then A plus C is equal to B plus C. So if I have something that says that, for example, if 5 equals 5, which is true, then in order to keep this true, if I take 5 plus 10, I'm going to have to take the other 5 and also add 10 to that to keep it so that they are equal to each other. Well, what if I take if x plus 2 is equal to 8, then what? Well, here we can subtract a 2 from both sides. So if I take x plus 2 minus 2, and as long as I do that to the 8 as well, it'll keep this equal. And so that would give us that x is equal to 6. So that would be using the addition and the subtraction property. There's also the multiplication and division property, which works kind of in the same way. If you multiply both sides of the equation by the same number, then it's going to keep the equation the same. So if I go back to that if 5 is equal to 5, which is true, then if I were to take 3 times 5, as long as I take the other 5 and multiply that by 3, it'll keep this being the same. What if I have that if x times 4 is equal to 24? Well, then I could go ahead and take x times 4, and if I divide that by 4, I can keep the same thing as long as I divide 24 by 4, as long as I do it for both sides. So 24 divided by 4, so that would give us x is equal to, I'm sorry, not 6, x is equal to 3. Or sorry, not 3, it's going to be 6, x is equal to 6. All right, the other properties to look at is one is called substitution, the other one is distributive property. Substitution property is when you can replace some sort of value. So when we have a substitute teacher for this example in itself, I'm not in the room anymore. Someone has come and taken my place. When you play a basketball game and you substitute for someone, they come off the court, you come on. You can only have 5 people on a court. So if x equals a, then a can replace the value of x. That's pretty much what that's saying. Same example of here, if I were to say that if x equals 2 times 3, then I could go ahead and take 2 times 3, so x is equal to 6. That's an example of substitution as well. There's the distributive property of if a times the quantity of b plus c, then a times b is equal to a times b plus a times c. So if I take if 3 times x plus 4, then I can go ahead and say that that is the same thing as 3x plus 12 using the distributive property. 3 other properties that I want to talk about, we just won't use all of them a whole lot at this point. One of them is the reflexive property, saying that a is equal to a. You can also use this for angles as well. So I could say that angle x is equal to angle x, and that's a reflexive property I could use for segments. Segment JM is equal to segment JM. When something is equal to itself, that is the reflexive property. Symmetric property just means that we can flip-flop things. If A is equal to B, then B is equal to A. So let's say if I have if x equals 5, then I can go ahead and say that 5 is also equal to x. And then the transitive property kind of looks familiar from Friday when we did the law of syllogism. And the law of syllogism is kind of linking these. So if A equals B and B equals C, then A equals C. And we talked about that on Friday. All right, so now taking that first one that I did here where I had us kind of organize these, trying to give reasons for what we are doing. We will always start out with a given statement. That's the problem that's given to us to solve. Then from there, how am I getting from the first step to the second step? Well, that first step here, we use the distributive property. So my reason is the distributive property. Now when I look at the next part to this, I say, well, how am I getting from 10 minus 6a minus 4a minus 28 to negative 18 minus 10a? Well, what's happening here is we're combining like terms. And when we do that, that's substitution. Then I take a look from here. Okay, I'm on step 3 and I'm going to step 4. What's different about the problem? Well, now I'm adding 18 to both sides. So that is our addition property. Once I get to that, now I am adding 18 to both sides. Well, that's 92 plus 18 is 110. We're just using substitution. Once I get to that part, now I can go ahead and use my division property. And once I divide and I take 110 and I divide it by negative 10, that's substitution again. All right, so there we have an example now of, and you'll notice that there's 2 columns, and this is a 2-column proof. On the left, you have the statement solving the equation, and then on the right, you have the justifications for it. Now, when you look at this too, there are going to be some parts that you can take a little bit of some shortcuts. And so I just want to kind of show you, this is really everything, and now I kind of want to show you how you can break this down a little bit more. So I'm going to go to here, just showing you the difference between a formal 2-column proof versus an informal proof. So I think even if you look at this here, you may probably choose to do a 2-column proof versus a paragraph proof. 2-column proof is a lot easier to follow versus a paragraph proof. Writing everything out and being concise with all your sentences can be a little bit much. So over here to the left, you'll notice that I'm pretty much explaining how to solve the equation by giving properties. All right, so I'm going to take you to 2 more examples right here for you to look at. One is the one that we just did, and another one is one that me not being there, we're not going to do this one. But here I have 2 examples where you can see that you are given a statement. So that's what you're starting with, and that given statement always comes first. And then we get down to what you're trying to prove, which is the very last and final piece of the 2-column proof. Now over on the left, you will see that I'm doing some different steps here, and you'll notice that I've included some substitution, which has been into this problem. And over on the right, I've actually taken out some of the steps of the one that we just did. So what I want to do is I'm going to go through another problem here and just kind of show you an example of what a 2-column proof could look like. So let's go ahead and say that we are given the equation of 7x minus 21 is equal to 42. And we are trying to prove that x is equal to 9. So we have 2 columns. On the left is going to be our statements, and on the right is going to be our reasons. Now, first thing that we always have to start out with is what is our equation that we are starting with, and that is our starting point in our given equation. That's your hypothesis. And ultimately what we're trying to do here is get to be that x is equal to 9. So I'm going to go over to the left right here, and I'm going to actually just rewrite this so that I can go through and solve it. What a 2-column proof is it's not a place to just show your work and solve it that way. It's actually just a space for it to be formally laid out. All right, so here's my equation. In solving this, I would want to, first of all, add 21 to both sides. So 7x is equal to 63. And after that, I would go ahead and I would divide by 7. And we are left with x is equal to 9. So if I want to make the most minimal number of steps for our two-column proof, then is the only ones that I'm going to include here are the ones that I wrote in blue. And I actually don't need to show my little chicken scratches here because that's going to be explained in the reasons. And so I started out with my given statement, and after that we added 21 to both sides and left me with 7x is equal to 63. And that was the addition property. So 7x is equal to 63, and that was the addition property. Then we went ahead and we divided, and so when we divided both sides by 7, we got that x is equal to 9, so that right there is our division property. So in minimal here, I could explain this in 3 steps. Now, for some of you, maybe you want to include a little bit more to this, and maybe you want to include all of this. So you could have done here that 7x minus 21 plus 21 is equal to 42 plus 21. If that's the case, then my addition property moves up a step. And this then would become substitution. This becomes substitution. And then if I wanted to show that I was doing the division, I could go ahead and do 7x divided by 7 equals 63 divided by 7, which is the division property. And then that would end up just taking my division property down here at the end and making that substitution. And so there would be an example of our proof. All right, let's try another one that I want to do with you. I'm going to go right here. So if 2 times the quantity of x plus 3 is equal to 4x plus 18, then x equals negative 6. So our given statement is the equation. 2 times the quantity of x plus 3 is equal to 4x plus 18. And we're trying to prove that x equals negative 6. Now what I like to do is I like to go ahead and just take these equations and I like to work them out first to make sure that I end up with that answer, as you should. In this case here, I'm going to use my distributive property, so 2 times x is 2x, 2 times 3 is 6, that equals 4x plus 18. And then I can go ahead and get my variables on the same side, so I can subtract a 4x from both sides. Negative 2x plus 6 is equal to 18. Subtract a 6 from both sides. So negative 2x is equal to positive 12. And then lastly, we can divide by negative 2. And we get that x is equal to negative 6. So good thing is that I ended up with that answer, and that's what I'm trying to prove. Going now over to my proof, I have my given statement, so that's where we're going to start. So there's my given. Next step that I did is I used the distributive property. So 2x plus 6 is equal to 4x plus 18. So that's the distributive property. Then from the red markings I have here, I subtracted 4x from both sides, which left me with negative 2x plus 6 equals 18. So that is the subtraction property. I added or subtracted 6 from both sides then, so that gives us negative 2x is equal to 12. So that's the subtraction property again. And then lastly, we divided, so x is equal to -6, and that's the division. So notice that with my final statement over here on my proof, I don't include all of my little markings here as far as like how I'm solving that, because that's being done in the explanation, and I'm able to see how you're going from one to the other. I'm going to go ahead and do one more example, I think. All right, so here's going to be our last example. Given that 7d plus 3 divided by 4 is equal to 6, prove that d is equal to 3. Some of you are going to feel that you can solve these without using space to go through it, and that's perfectly fine. But I know that some of us are still struggling with solving equations from Algebra 1, so I'm going to make sure that I'm showing you how we're doing that. So since I'm dividing our fraction here by 4, I will first of all multiply both sides by 4. So 7d plus 3 is equal to 24. From here, I could subtract 3 from both sides. So 7d is equal to 21. And then I can go ahead and divide by 7. And now d is equal to positive 3. So I go through the steps. I've got 7d plus 3 divided by 4 is equal to 6. That is my given statement. I multiplied both sides by 4, which gave me 7d plus 3 equals 24. So that's the multiplication property. I subtracted 3 from both sides, so 7d is equal to 21 using the subtraction. And then I divided by 7, and so d is equal to 3, and that's the division. All right, so now hopefully you've got a decent feeling about this. Hopefully you put a few of these into your notes. Once you're done with this, you can go ahead and grab the assignment and begin trying to work on that. It may help to work with someone else as you work on it, just to kind of help clarify anything.